In this video, we're going to start the KutaSoftware Infinite Algebra 1 free worksheet solving equations by completing the square. Now this worksheet has a total of 24 problems, so I'm going to do 8 problems in each video. And in this first video, lucky enough for us, for the quadratic ax squared plus bx plus c equal to 0, we're only dealing with a values of 1. So because a equals 1, in order to complete the square, that means that we need a c value equal to b over 2 squared. And if you remember a few worksheets ago, we did a video just on completing the square. So if you're confused on this formula, refer back to that worksheet. I'll leave a link in the description below so you know how to access that. Now, another important thing to note, that because we're solving these quadratics and we're completing a square, essentially we're going to create a plus b squared or a minus b squared. So I'll write down the formulas for those real quickly. A plus b squared is equal to a squared plus 2ab plus b squared. And a minus b squared is a squared minus 2ab plus b squared. So just remember that when you're adding a and b, you add 2ab, and when you're subtracting a and b, you're subtracting 2ab. So now let's go over the steps for solving each equation. I know that this c value does not equal b over 2 squared. So what I'm going to do is I'm just going to add that to the other side. So I'll have a squared plus 2a equal to a positive 3. Now I'm going to create a c value that equals b over 2 squared. So if my b value is equal to 2, then c is going to equal 2 over 2 squared, which is 1 squared, which equals 1. So now to this equation, I'm going to add 1. So I'll have a squared plus 2a plus 1. But since I added 1 on the left-hand side, I'm going to also need to add 1 to the right-hand side in order to not change the value of the overall equation. Because of that additive inverse property, c plus a negative c equals 0. So when I added that c value of 1 in, a squared plus 2a plus 1, I also needed to take it away. So I also subtracted 1, and that was equal to 3. Then, if I was to add 1 to both sides, you can see that's where I'll get my 3 plus 1. So adding c, whatever I do to the left, I need to do to the right, does not change the value of the equation. So now you can see that a squared plus 2a plus 1 is in the form of a squared plus 2ab plus b squared, where that b value is 1 and the a value is simply a. So I'm going to rewrite that as a plus 1 squared, and that's going to be equal to 3 plus 1, which is 4. Now that I've completed the square, on the left-hand side of my equation, I can just take the square root to get that a plus 1, because the square root of a plus 1 squared will cancel out to be a plus 1, and that's going to be equal to the square root of 4, which is either a positive 2 or it's going to be a negative 2, because remember, a negative squared is also a positive, and negative 2 squared is equal to positive 4. So now I'm going to subtract 1 from that first equation to get that a is equal to a positive 1, and I'm also going to subtract 1 in the second equation to get that a is equal to a negative 3. So when I solved this equation by completing the square, I got my solutions as 1 and negative 3. So 1 and negative 3 are my solution in number 1. And I just wrote those in set notation. A equals 1 and a equals negative 3. Let's continue on to number 2. In number 2, as opposed to adding 8 to both sides at the start, I'm going to focus on my c value. So I want c to equal b over 2 squared. And in this case, my b value is equal to a negative 2. So now I'm going to have negative 2 over 2 squared. Negative 2 over 2 is a negative 1. And when I square that, I get positive 1. So I'm going to add this positive 1 and subtract that positive 1 in my equation in number 2 so I don't change the value. So I'll have a squared minus 2a, and then I'll add 1 and subtract 1, essentially adding 0, and then I still have to have minus 8, and that will equal 0. Now, a squared minus 2a plus 1 is in the form of a squared minus 2ab plus b squared. So I can rewrite this as a minus b squared, where my a value is simply a, and my b value is that positive 1. So I'll have a minus 1 squared, and then I'll combine my like terms, 1 and 8, to get minus 9, and that is all equal to 0. So now, I'll move that 9 to the other side by adding 9 to both sides to get that a minus 1 squared equals a positive 9. You can see that that's the same value on the right-hand side that I would have gotten if I added 8 and then added 1 to both sides, because 8 plus 1 is 9. Now, my next step, I'm going to be taking the square root of both sides. So I'll get that a minus 1 equals a positive 3, since the square root of 9 is positive 3, and I'll also get that a minus 1 equals negative 3, since negative 3 squared will also give us a positive 9. So I'll add 1 to both sides in my first equation to get that a equals positive 4. And then I'll add 1 to both sides in my second equation to get that a is equal to a negative 2. So my solutions in number 2 are 4 and negative 2. So by adding c to both sides, essentially we're adding 0 to the equation. Let's continue on with number 3. I'll complete number 3 like I did in number 1 by moving this constant to the right-hand side at the start. So I'll add 22 to both sides. So I'll have p squared plus 16p equal to a positive 22. Now we need to complete that square on my left-hand side. My b value is a positive 16. So c is going to equal 16 over 2 squared, b over 2 squared. 16 divided by 2 is 8, and 8 squared is equal to 64. So I'll add 64 to both sides. So I'll have p squared plus 16p plus 64 equals 22 plus 64. So now I'm in the form of a squared plus 2ab plus b squared, where a is p and b is a positive 8, since 8 squared equals 64. A plus b squared. And that's equal to 22 plus 64, which equals 86. Now I'm going to need to take the square root of both sides, which will give me two separate equations. I'll have p plus 8 equal to the square root of 86, and we'll do the positive square root of 86, which is 9.2736, which I will round to 9.274, although on the answer key they had rounded that to 9.273. So 9.274, because I'm rounding up, and then I'll have p plus 8 equal to a negative 9.274, because negative 9.274 squared is also equal to 86. So I'll start by subtracting 8 from the first equation to get that p is equal to a positive 1.274. And again, on the answer key, they got a positive 1.273 just because they rounded a little differently. Then for the second equation, I'll subtract 8 from both sides to get that p is equal to a negative 17.274. And on the answer sheet, they got 0.273. However, I rounded up as opposed to just truncating or rounding down. So my solutions for number 3 are 1.274 and negative 17.274. Those are my solutions when I solve by completing the square. And if you want to double check, feel free to use the quadratic formula, and you will indeed get the same solution. Moving on to number 4, again, I'm going to move my constant to the other side of my equation. So I'll have k squared plus 8k equal to negative 12. Now I'm going to complete this square on my left-hand side by adding c. b in this case is equal to 8. So my c value, b over 2 squared, is going to be 8 over 2 squared, which equals 4 squared, which is 16. So now my equation will be k squared plus 8k plus 16 equals negative 12 plus 16, since we're adding 16 to both sides so that we do not change the value. Now, k squared plus 8k plus 16 is in the form of a squared plus 2ab plus c, where my a value is k and my b value is a positive 4. 2 times a times b, 2 times 4 times k is 8k, and b squared, 4 squared is 16. So a plus b squared equals negative 12 plus 16, which is a positive 4. So now I'll take the square root of both sides. So I'll have two separate equations. I'll have k plus 4 equal to a positive 2, since the square root of 4 is 2, and I'll have k plus 4 equal to a negative 2, since negative 2 squared equals a positive 4. Now I'll subtract 4 from each of these equations, and doing so on both sides. So I'll have k equal to a negative 2, and I'll have k equal to a negative 6. So negative 2, negative 6 are my solutions in number 4. Moving on to number 5, I'll move this constant to the other side. So I'll add 33 to both sides of my equation. So I'll have r squared plus 2r equal to 33. But I'm going to need to find that c value and also add that c value to the other side once I find it. So adding c to both sides. My b value in this case is a positive 2. So my c value is going to equal b over 2 squared. 2 over 2 squared. So c is equal to a positive 1. Now rewriting my equation above, I'll have r squared plus 2r, and I'll substitute in my value of c, which is 1, and that will equal 33 plus 1. So this is in the form where my a value is r, and my b value is 1. So r plus 1 squared equals 33 plus 1, which is 34. So now what I'm going to do is take the square root of both sides. So I'll have r plus 1 equal to the positive value of the square root of 34, and I'll have r plus 1 equal to the negative value of the square root of 34. And the square root of 34 equals 5.8309, which I'll just round to 5.83. So we'll have 5.83, a positive, and a negative 5.83. So when I subtract 1 from both sides of this first equation, I'll get r equal to a positive 4.83. When I subtract 1 from both sides of the other equation, I'll get r equal to a negative 6.83. So my solutions in number 5 are 4.83 and negative 6.83. In number 6, a squared minus 2a minus 48, I'm going to start by adding 48 to both sides. So I'll get a squared minus 2a, and then I'm going to be adding c to this eventually. That will equal 48, and then adding c to that as well. Because if I'm adding c to the left, I'm going to need to add c to the right. So now let's solve for what that c value is in order to complete this square. If my b value is negative 2, that means my c value is going to be negative 2 over 2 squared. So that's going to be negative 1 squared, which equals a positive 1. So now substituting my c value in, I'll have a squared minus 2a plus 1 equal to 48 plus 1. Now this is in the form of a squared minus 2ab, so I'm going to have a minus b squared. So that's a, since my a value is a, and my b value is 1. A minus 1 squared. That's going to equal 48 plus 1, which is 49. Now I'll take the square root of both sides, remembering to take into account my positive and my negative values. So I'll have a minus 1, and the positive square root of 49 is 7, and then I'll have a minus 1, and the negative square root of 49 is a negative 7. That's because when I square negative 7, also equals a positive 49. Or you can almost think of this as squaring the negative square root of 49. That would be equivalent to the opposite or negative square root of 49 times negative square root of 49, which we know a negative times a negative is positive, so that will give us a positive 49. So continuing on, I'll add 1 to both sides of my equation to get that a equals 7 plus 1, which is 8. Then I'll add 1 to both sides of my other equation to get that a equals negative 7 plus 1, which is a negative 6. So my solutions in number 6 are 8 and negative 6. Now if I haven't said so before, what this means when I solve for the solution, it means that I can plug 8 in for a, or I can plug negative 6 in for a, and the left-hand side of this equation will equal 0. That's what it means to solve. We're solving for the variable value that will make this equation true. Let's continue on to number 7. In number 7, I have m squared minus 12m plus 26. So I'll subtract 26 from both sides. That'll give me m squared minus 12m, and in order to complete that square, I'll need to add some c value. And then I'll have negative 26 on my right-hand side, and then I'm also going to have to add the c value to that as well. Since I added it to the left, I'll need to add it to the right. Now, in order to complete this square, I'll see that my b value is a negative 12, so that means my c value will equal negative 12 over 2 squared. Negative 12 over 2 is a negative 6, and when I square that, I'll get a positive 36. So I'll have m squared minus 12m plus 36 equals negative 26 plus 36. Now this is in the form of a squared minus 2ab plus b squared. So my a value is m, and my b value is 6, because 6 squared is 36, and 2 times 6 is 12. So m minus 6 squared equals negative 26 plus 36, which is a positive 10. So what I'm going to do is take the square root of both sides to get that m minus 6 equals the positive square root of 10, or m minus 6 equals the negative square root of 10. Now I'm just going to add 6 to both sides of this equation to get m equal, and then I'll type this into my calculator, the square root of 10, close the parentheses, and then add 6 to that and get 9.162. And then I'll add 6 to the other side, so I'll take m and get negative square root of 10, typing that into my calculator, closing that parentheses, and then adding 6 to that. I'll get 2.8377, which I'll round to 2.838. So as opposed to writing the square root of 10 in decimal form, I left it as an exact value and then added my whole number on my calculator. So my two solutions in number 7 are 9.162 and 2.838. And on the answer key, they have 2.837, but I just rounded the 2.8377 up to 2.838. And now, lastly in this video, number 8. However, before I go over the answer to this, please remember to like this video and subscribe to my channel. Now, for number 8, we'll start by subtracting 20 from both sides. So I'll have x squared plus 12x equal to negative 20. Now I need to solve for the c value, which completes the square on my left-hand side. If my b value is a positive 12, my c value is going to be 12 divided by 2 squared, which is 6 squared, which equals 36. So I'm going to have x squared plus 12x plus 36, and that's going to be equal to negative 20 plus 36. Since I added a 36 to the left, I need to do so to the right. Now x squared plus 12x plus 36 is in the form of a squared plus 2ab plus b squared, where my a is x and my b value is 6. So x plus 6 squared equals negative 20 plus 36, which is a positive 16. Now, taking the square root of both sides, I'll get that x plus 6 is equal to a positive 4, or x plus 6 is equal to a negative 4, since the square root of 16 is both positive 4 and negative 4. Now, I'll subtract 6 from both sides of my first equation to get that x is equal to a negative 2, since 4 minus 6 is 2. And then I'll subtract 6 in my second equation to get that x is equal to a negative 10, since negative 4 minus 6 is negative 10. So in number 8, my final solution is negative 2 and negative 10. If you didn't do so before this problem, here's a friendly reminder to like this video, subscribe to my channel, and also feel free to share it with your peers. Continue on to the next video where I'll complete the next 8 problems, 9 through 16. And in the last 2 of those, I'll be introducing how to complete the square and then solve the quadratic when the a value is not equal to 1.